Tell me about PG Lake, Marco.
So yeah, PG Lake is a way to query your data lake from Postgres essentially, and to manage data in your data lake from Postgres. So, I mean, I've always felt that Postgres was a bit, like it's a good operational database, but it's a little bit disconnected from the rest of the world. Like there's, you can put, it's like this little island that you can put data in and you can get that data out, but it doesn't interact with other systems very much. So, and of course there's like, there was this whole other area of analytical databases. I mean, Snowflake traditionally, and, Databricks, Redshift, and more recently DuckDB, that kind of have introduced this sort of experience of, hey, here's a file in object storage, which is where everyone's storing their data now. Let's just query this file in object storage, like just a select star from file. And so I think, one of the ideas was like, can we get that type of an experience in Postgres? Because there's tons of people who have data in object storage that they want to get into Postgres. And also vice versa, can we easily get data from Postgres into object storage? And then, the traditional way to do that is like CSVs and parquets, and then let's say the more modern way to do that is Iceberg in S3, and actually Iceberg has this very nice mapping into Postgres in a way. It's like all of the Iceberg features, they're already also Postgres features, so you can kind of make a very nice experience for managing Iceberg tables in Postgres.
So you released this thing in November, so it's been now 4 months. We're recording this in February 26th. When did you start building this thing? Was it always supposed to support Iceberg, or was it just first focused on the CSV and Parquet thing?
It was always focused on Iceberg. I mean, I think PG Lake is sort of a few things coming together. So I mean, one of the ideas is like, okay, Postgres is very disconnected. The other idea is Postgres is getting really far behind on analytics compared to the analytics databases, where many modern vectorized query execution engines on columnar storage will just go 100 times faster than Postgres on the same query on the same data on the same hardware. And we were kind of quite aware of this problem for a while, because in a past life I was working on Citus, which is this scale out Postgres solution, and a lot of companies that came to us, they were basically looking for a Postgres data warehouse, and I mean, scaling out is not really the cure for kind of analytical data warehouse solutions, or at least not just by itself. So we knew a lot of companies had this need, and it wasn't being fulfilled by the existing systems. There's some older forks, but people want current Postgres. And so we kind of looked at how do you make Postgres fast for analytics, and then we've done some experiments in the past with putting columnar storage into Postgres, but realized that really architecturally it's just not built for it in any way. But also from the Citus days, we kind of knew that Postgres is extremely extensible, so you can take entire queries and just do something completely different from what Postgres would normally do. Mm-hmm. And then at the same time, I was talking more and more to people from DuckDB who are here in Amsterdam, and they were building this vectorized query execution as a sort of open source embeddable thing. So here we have Postgres being slow at analytics, but it's very extensible. Here there's DuckDB, which is embeddable, very fast, and can also talk to object storage. So can we bring those two things together? And then Iceberg was basically the natural way to make that a very kind of to have a sort of modern analytics optimized storage format that we could plug into Postgres. And this was in 2023 when we started kind of planning this, and it was not that obvious that Iceberg would even win. Like Delta was actually looking like it was winning at the time. It was just like Iceberg was actually fit our needs very well at the time.
Yeah, that makes a lot of sense. I mean, if you have data in object storage, you would want some sort of standard to interoperate between. Well, I have a lot of questions from this. You hinted at a lot of things. I guess my first question is how does analytical data even end up in Postgres? Or can you talk to me more about that experience of customers coming and wanting you to scale out the Postgres because it did not scale, I guess? Is that, were they trying to scale out for OLAP data, meaning they wanted to run analytics on the data they've accumulated on Postgres and they just wanted to find a way to make that work? Or how do you generally see this, analytical data in Postgres or outside? What does a typical organization in your experience hit first?
Yeah, I think there's often this sort of almost natural evolutionary path where you built your app, you have an application, some Python, some Ruby, some whatever, and you have Postgres, and that's what you have on day one. And some apps work really well; they become popular, and you start adding all the features that your customers are asking for. And 2 years later, you find yourself, okay, maybe you have multiple application servers, but you're on Postgres because it's not that easy to split up Postgres or to just quickly migrate to something else.
Yep.
So, and a few years down the line, maybe you want some dashboards for your customers, or you want some internal dashboards, and it's still just easier to build it on Postgres where the data already is. So Postgres tends to be this sort of spiraling source of data, and at some point it just kind of grows out of its capacity. And then there's the question: do you start investing in more ETL, more Kafka, more just shovel the data over into other systems, building out that whole architecture? And most companies eventually do start doing that. But of course, the first thing that a lot of companies do is look for the quick fix. If I scale out, does that solve my problem? And for analytics, it often doesn't. But I think PG Lake is actually a bit closer to solving that, where it's just okay, well, you can keep using the same system. It's just now faster. So that's usually, I think, the most common motion.
Well, when you say PG Lake makes it faster, in what way? How does it make it faster? Is it because it's embedding the columnar engine of DuckDB?
Right. Yeah, so in PG Lake you can create Iceberg tables pretty much the same way you create Postgres tables, but then when you query those, it'll the extension will sort of kick in, and it'll either take part of the query plan or take the whole query plan, and then sort of transform that into two pieces, sometimes multiple pieces, one piece of which will get delegated into DuckDB, or actually DuckDB running alongside Postgres. And DuckDB will be operating on the Parquet files that are in the Iceberg table, which are often also, we cache them locally, so it's sort of working on local Parquet files. And then through its kind of parallel vectorized execution engine, analytical style queries will just go really often 100 times faster through that method than they would if you were doing the exact same query using a regular Postgres query plan on regular Postgres storage.
Right, and continuing with our example, but you first have to move the data in some way, right?
Yeah. So this would be more like you either switch to just storing your data in Iceberg, or you have some kind of incremental way of moving the data over. And increasingly, we're also working on tools, of course, for just doing sort of more out-of-the-box logic replication. But often there is a type of batching that happens as well.
Right. Yeah, I want to talk about that later too. So we touched on this idea of an organization gradually growing its data set in Postgres, and eventually they would move it out to, let's say, Iceberg and S3 and query it, let's say, with PG Lake, or to some other system. That's the sort of the organic way. Do you think there's also a use case in existing organizations which already have data in, be it another system, be it maybe they already have it in Iceberg? Do you think there's a use case for somebody to adopt PG Lake in that sense? Like my data is already there, give me a way to query it through my Postgres and my tools.
Yeah, I mean, certainly like getting, I mean, if currently you have data in Iceberg and maybe a dashboard built using kind of an analytical data platform, very often you open the dashboard and I mean, you probably don't have to wait 5 minutes, but you probably have to wait like 30 seconds, 60 seconds. And if this is actually something that's like customer facing, then that's a pretty terrible experience. Like internally, you sort of often accept it. It's okay. If I want to see this number, I'm just gonna sit here for a bit. But so, and then the way to make that fast is often just like, move the data over into Postgres. And so there it's like, okay, I have data in Iceberg now in Postgres. I can create materialized view, select star from Iceberg or something like that, add an index. And now that query is 4 milliseconds or something along those lines.
Can you dive deeper into how that works? What does it mean when you say move that data into Postgres?
So let's say in the PG Lake case, so your Postgres server can query the Iceberg table directly via DuckDB, but it's still in itself is probably going to take a few seconds or like if it's a massive table and we actually need a huge part of the table, maybe it takes a few minutes in some cases still. Like even though it's much faster than having that same data set in Postgres and scanning it, it's still not instant. Okay. But because you have it queryable in Postgres, you can just do Postgres is almost this general purpose computing box that you can write programs for it, like procedures or queries. And so you can do inserts into Postgres tables, select from the Iceberg table, you can do create materialized view. So essentially that's moving the data. It's just doing it via a single SQL command that's actually also a transaction. While you're doing those writes, you also get the indexes updated and then immediately you can do the fast lookups.
So will it be more akin to a cache when you say move the data? Does that mean I'm imagining a query that's something like select star, or we can probably try to figure out a practical example. But if you're trying to aggregate some dashboard, some historical view of like some chart data and the latest number, would it be something along the lines of that query would do? Select star from Iceberg, group by whatever in Iceberg. And then you insert that aggregated result, which is significantly smaller than the dataset you have to traverse to compute it, into an actual Postgres row-based table.
Right. Yeah. And then the aggregation, there's a few different scenarios. So in the way you're describing, let's say the aggregation happens from Postgres, but because it's on the Iceberg table, it can still be delegated into DuckDB, and so it's reasonably fast. And then we insert, and then there's almost like two variants of that. One is like we sort of fully rebuild the Postgres table every time we do this, sort of more the materialized view option, and then there's also a more incremental option where you say, okay, I keep when I select my aggregations, maybe I'm aggregating like a day or an hour worth of data, and I remember that I processed that hour, and then the next time I run my aggregation function, I'll just move on to the next hour. And so that way you can actually scale this to pretty large data sizes because you're only doing incremental work, and it's relatively easy to do this in Postgres because you can always just do these transactions where you insert something, you do your bookkeeping, you insert something, you do your bookkeeping.
Right. Yeah, and everyone is familiar with that already. So from that point of view, can you explain to me a little bit more do you have an idea of how much resource usage that might ask for from the Postgres? If I understand correctly, again, when you query the Iceberg, you're using the DuckDB engine. One of the key things here for efficiency, as far as I understand, is pruning a lot of the columns in that. So you have a big Parquet file in Iceberg that has a lot of data, and you only probably care about a small subset, let's say, for your user from that data. So I guess one of the big efficiencies here is that we're pruning a lot and we're not reading a lot of the stuff we don't need to read. And then on the aggregation side, whatever it pulls from the Parquet, it goes into the Postgres box, in the DuckDB engine in the Postgres box, and then it does that aggregation. Can you imagine that taking significant resource usage from the Postgres?
I mean, I think we try to make sure that when you do this style of query where you're maybe inserting into a Postgres table, selecting from an Iceberg table with a group by and some filters, that basically none of the work will happen on Postgres except for the writing to the table. Because in PG Lake, the query planner will kind of go and sort of analyze the select and see which part of this select can be delegated into DuckDB. Now, what's nice about DuckDB for this purpose is that they started out with a fork of the Postgres parser, and they tried to sort of re-implement all the Postgres functions with mostly same name and some semantics, some exceptions. And so very often a Postgres query can actually delegate into DuckDB, or with some rewriting or some extra sort of under the covers transformations can be delegated into DuckDB. And in that case, it's really you can use the full power of your machine, essentially, like use all the cores, like Postgres. Postgres is fundamentally kind of single-threaded when it processes a query, so that's often a big bottleneck. And then vectorized execution makes a tremendous difference, because it's there's like one layer of pruning, so we only scan the Parquet files we need. Within the Parquet file, maybe we only scan the row groups that we need, and within the row groups we only take the columns that we need. But then the nice thing about vectorized execution is if Postgres takes a whole bunch of rows and needs to process them, needs to aggregate them, it takes one row and evaluates the first expression in the where clause, then the second expression, then the aggregation, then goes back to the next row, first expression, second. And there's so many sort of CPU instructions associated with kind of going up and down the function call stack. And you're not using your CPU cache very efficiently. And it also, because Postgres is following all these function pointers, because every operator is essentially like a function pointer to somewhere, to an extension, to Postgres itself. The branch prediction in your CPU kind of is really poor. You send internally, the CPU is like a network where you send a bunch of instructions to the internal processing, and you kind of want to send a batch, because then it gets high throughput. But if you have a sort of a jump to some random place in memory, your batch sort of breaks. So you're sending only these very small bits of instructions into your CPU. Whereas if you take vectorized execution, you essentially take a block of data. Your operator is essentially a loop over that block of data. And then, so that sits in cache. Your pipelining works really well. We can send a bunch of instructions into the internal processing unit. And then on top of that, many modern CPUs have these SIMD instructions, so they can take 100 values at a time and process it at once. And so that adds up to this enormous boost in performance for these types of queries. So we try to kind of get most of the work in those of that aggregation work into DuckDB, but you are still on a single machine. So if we need to reprocess a petabyte of data, even DuckDB is going to take a long time. So the incremental nature is, I think, where it gets really interesting, that because it's easy for us to do the bookkeeping on Postgres, we can just effectively do incremental processing.
That's really interesting on the deep dive on the CPU optimizations there. But I was, 1 petabyte for sure would be high. I was more thinking of, from the point of view of shooting yourself in the foot accidentally, in a way. One thing I don't exactly comprehend is how these extensions work is, okay, you're opening me up as a user, as an app developer, to run a select from whatever this Iceberg table. Is there any is it easy to shoot yourself in the foot, I guess, is my first question. If I query accidentally a 1 petabyte table, have you seen that in production? Have you seen people do that? What happens if you do that?
Yeah, I guess your machine will spend a lot of time downloading stuff from S3, and then at some point you'll probably cancel the query because it's it's taking too long. Yeah, I think there's like almost like there's two layers of foot guns. There's the this is actually too big for my machine foot gun, and then there's the actually work starts leaking into Postgres foot gun, where we like, even though DuckDB can handle a lot of the queries that Postgres does, but maybe you're doing something a little bit more funky. You're joining with Postgres tables. You're introducing your own functions. And then, the planner will try to answer the query, but it might not be able to do it fast anymore. And that happens. And of course, there's explain tools where you can see the query plan, and it will tell you like which function is the problem. So that's helpful. But I think with the petabyte, it mostly causes network, but it usually doesn't bring down the database so much, because it just gets like the database is usually a bit less network bottlenecked. I guess if you have other queries that are using a lot of network, those are also going to get slow. So it's definitely something to be
when you download these things, do they go into RAM or do they get offloaded into disk?
No, I mean there's two, I think now actually 3 layers, but like so. DuckDB has its own buffer manager that spills into disk, and disk in our case would often be like an NVMe drive or something like that. We also have this file cache. Now we're not like a sort of traditional, but like we're not like a sort of read-through cache where if you read the file it immediately goes through cache. So we're kind of just fetching these in the background based on usage patterns. So if you're just running the query for the first time, it's not immediately spilling to disk, but it'll start a little bit afterwards, looking, all these files have been fetched recently, so let's download the whole file. And this is partly because when you're doing the query, probably you very rarely actually fetch the full file. You're probably just going to fetch a little piece of it, so we don't download the whole file at query time.
Got it. So you wouldn't run out of memory per se. You may run out of disk if you really fetch a lot.
Yeah,
I mean, foot guns are normal. I mean, even with normal Postgres, you can foot gun yourself very easily.
Oh, very easily.
So no question.
Yeah, we've seen plenty of outages, which was just the application started doing a select count star from table, and that brought down the database, because like in the Postgres world, that's just actually going to scan all of the data, like all of the columns. Or
like some bad update that locks the table for every other production query. I've seen that as well. So that is dangerous. So about the architecture of PG Lake, then you said something about the fact that Postgres queries are all single thread because they run in. Actually, are they single? They're in one process, right?
Yeah. So it's a process-based architecture. So every connection makes a new process, it's been this way since the 1980s.
Yep.
Originally. Like there's this famous paper, The Design of Postgres by Michael Stonebreaker, which says, we're going to use processes because that's what's available on all the operating systems, but we should really switch to threads once it's like widely in use. That hasn't happened yet, although there is ongoing effort to make it use threads. But basically within the process...
When was this written?
I think 1988.
In the 88, oh my god. Wow.
Yeah, so there has been this, 40-year plan to make Postgres switch to threads. It might actually happen in like 2 or 3 years that we have some form of multi-threading in Postgres. Like a query is typically executed within that process that gets spawned when you make a connection. There is a kind of parallel query mechanisms where there's some worker processes that can do parts of large scans. In practice, it doesn't always work very well. Maybe like if no workers are available, the query will still get single process. Also because it doesn't share address space with the other processes, there's all these kind of shared memory queues for passing results. So it's really a lot slower than some of the sort of multi-threaded analytical query processing.
Right, and now that you run, PG Lake runs DuckDB as a separate server,
Right,
not
right.
as part of the process, which would be part of, let's say, a query process, a connection process. Does that allow DuckDB? Does that allow you to run on all threads?
Yeah, for sure. So that's one of the reasons where, we could have embedded DuckDB directly into Postgres itself, but then, you get every process has a DuckDB, which has a thread pool and a buffer pool, and ideally wants 80% of the memory. And so like that works if you're doing one query at a time, but if you're doing 20 at a time, it's already going to get very problematic. So we have this separate process, and then the Postgres processes connect to that process just via some internal network protocol. And so that just runs DuckDB at, let's say, full speed with all the threads, with 80% of the memory. Well, you can configure the memory, but like with a big chunk of memory and its own caches.
How come DuckDB wants 80% of the memory, and doesn't that hurt Postgres as well?
Yeah, we tune it down a bit to I think we set it to 50 by default, and it's just it's a command line argument at this point. But definitely it's that's one thing to be. Let's say if you're running PG Lake yourself in production, like this is something you need to be like probably the most important tuning parameter, because you're going to have to decide like how much memory goes to Postgres and how much goes to DuckDB, because they both like having a big buffer cache where Postgres wants to cache its pages and its catalogs and everything, and DuckDB wants to cache chunks of Parquet files, or at least have like enough space to cache its internal vectors. So that's so usually we do a little bit of 50-50 for systems that do actual analytics. For systems that are more just pulling stuff from object storage, the percentage can be a lot lower. Like DuckDB is also fine with like 20% of memory. It's just then you shouldn't expect it to be as fast at analytics.
Yeah, it's the oldest trade-off in the world. If you want performance, you need more resources. It might be fair to just vertically upgrade that machine too, if you're gonna.
And I think that's generally what happens. It's one thing we've still trying to get a good handle on is like in analytical systems the sort of failure modes are a little bit more bursty or something. Like in Postgres, if you're running out of memory, you're just going to see some percentage of your queries gradually build up, like starting to throw out of memory errors, and it's like, okay, now it's time to scale up. But in analytical systems, it's like, oh, there's suddenly a lot of work to do and suddenly a lot of memory, and so we get a bunch of failures, and then nothing happens for a while, and then an hour later, you suddenly have a bunch of failures, and you kind of feel like it feels more like something is wrong than that you're just under provisioned, but.
That's the footgun thing we talked about, isn't it? Because it's so trivial to run a huge query when you have a large data set.
Right. Yeah, so it's, for the, I guess where it gets tricky is like if the queries are very ad hoc, like if you're just sort of running this periodic aggregation job, incrementally processing the incoming data, it's like, okay, it's going to do approximately the same thing every time. I think where the memory gets a little bit more iffy is, like if you do sort of some combinations of complex joins and sorting and window functions and CTEs, like the amount of memory that the query really needs, as in cannot necessarily all spill to disk, kind of goes up a lot. And so that's the tricky one. If there's sometimes it's still dashboards that do this. Sometimes it's people typing queries. Sometimes it's agents generating queries. That one is that's where it gets a bit trickier.
That's an interesting point. Nice. And another thing about the PG Lake. So PG Lake has its own query parser, right?
Well, like it kind of the query goes through a bunch of stages. And the query gets parsed by Postgres, so that's something we we cannot even really change as an extension. The query gets parsed by Postgres, and then maybe we can get in once it's happy about the query tree. But then, so we kind of, so there's a sort of fast path we have where we see, oh, the whole query is just touching Iceberg tables or Parquet files and things that we can delegate. And so then the query tree then gets kind of transformed into a DuckDB compatible query tree, and then it gets converted into SQL that DuckDB understands. That's the sort of fast path. The not as fast but still pretty fast path is like if not all of the query can be delegated, we'll actually go through sort of Postgres' regular query planning process. So the query will get broken down into a sort of logical plan. Postgres internally calls this paths, but it's basically different. Like it sort of starts evaluating different ways in which it could execute different parts of the query tree, and then we start working on this logical plan data structure and analyzing which parts of it could be delegated. And so this is like, we look at sequential scans, we look at aggregations, and window functions have their own plan nodes, order bys, joins. And so we kind of, it's essentially it's a query tree. So we work through this query tree, or it's a plan tree. We work through this plan tree from the bottom up, and we find the biggest subtree that we know we can safely delegate. And at some point we might find, some node has some filters that can be delegated, some functions that can be delegated, but some functions that cannot. And we actually sort of split the plan at that node. And then everything below that plan kind of gets converted back into an ASD, like a query abstract syntax tree, which then gets converted into DuckDB SQL. And the rest of the plan just gets converted into a Postgres query plan. And that middle node, that's essentially the glue that becomes our custom scan, which is handled by the extension. So Postgres then just starts executing its query plan like usual, and at some point it starts asking the custom scan for rows, and then the custom scan runs the SQL that it generated on DuckDB. It'll start returning rows, and it'll pass those into the Postgres query executor. So it's complicated machinery.
That sounds like a lot of work. Why did you choose that? What are the practical benefits of having that?
Yeah, I mean, it's really to maximize what we can delegate into DuckDB, which maximizes performance essentially, and also avoids these really harsh cliffs. Like, you could say, okay, does the whole query delegate into DuckDB? No, then we'll just do whatever Postgres does, and at the bottom we'll get the Parquet data from DuckDB, right? But that's not what you want, because then it does get slowed, and you don't take advantage of all the vectorized execution stuff because all the work moves into Postgres.
So wait, right? So if you have a big query, let's say, and if you did not have this custom scanner, I guess it's called, it's not a parser. Mm-hmm. If you didn't have this custom scanner, you had a big query, and parts of it could be delegated to DuckDB, but other parts couldn't. You would have to basically not delegate anything. You have to keep it in Postgres, and that would be very slow. Okay, that makes sense. But when we say delegate to DuckDB or process in Postgres, what I'm sort of missing is the end-to-end here. So if let's say my query is reading or is trying to read from a remote table, a remote Iceberg table that's in S3 somewhere, that has to go to DuckDB to even read the S3 table, right? So what does it mean when you say, like processed by Postgres versus like?
Yeah, I mean, well, like you always need something like this, but like the simplest form of it is just to say, okay, at the bottom of the query plan is where we scan the table, and if we cannot delegate the whole query into DuckDB, we'll just replace those scans with things that do select star from Parquet, let's say, in DuckDB, and then the results from that go into Postgres. And so that, I mean, that's simple to implement, to be honest. Like that's very, very straightforward. But then you get this bimodal of like, oh, either the whole query is fast or the whole or it's very slow. But then like all the like the tricky piece is to get to have part of the query plan or parts of the query plan as much as possible delegate. Like that's where you need the whole logical planning business.
So talk to me like a Postgres noob, because I'm more of a database noob. We can step back to a higher level, I guess. So you have a query, what can I think of? I don't know. Select star from Iceberg table where ID equals 1, and I don't know, maybe some group by whatever, purchase order or whatever. If we think about something like that, that query has parts where first it has to fetch that data from Parquet.
Mm-hmm.
And then it has parts where that fetch data needs to get aggregated by the group by the where, by the, I could say, what can I say? I can select certain columns that I, let's say, sum together or something inside the Postgres SQL. How does that query at a high level get split by? Is there some part that just has to first like fetch or scan the table, as you said, and then another part has to perform the where filtering, then the aggregations, then the sum? Let's say my select is, select column A plus column B, something like that.
Mm-hmm. Yeah, I mean, like a lot of the time that query will not get split, but I mean, where it will get split is the point. So I mean, we sort of have this like allow list of all the functions and operators that we are happy to delegate. Mm-hmm. So, and then in the Postgres logical plan, like each, like let's say your where clause becomes a list of functions somewhere in the plan, and we go through that list of functions and it's like check is this all in the allow list of functions that we know that DuckDB also has, and if yes, then great, then this whole query can delegate. But if we see like part of the list is in the allow list and part is not, then we'll sort of construct a query that goes to DuckDB that has the filters that are in the allow list. Mm-hmm. And so that's the query that we run on DuckDB. And then this this custom scan node will have, you'd say, the filters that weren't on the allow list. So it'll and let's say if you create your own function, then by definition it's not on the allow list. So that's a very easy way to trigger this sort of splitting behavior. There are certain Postgres functions. A lot of it is just really, PG internal functions, like some function that looks at the current process ID or something, or a bunch of random stuff. Mm-hmm. But maybe some more exotic math functions in Postgres that for which there's no equivalent. Mm-hmm. So then that part of your where clause will get done in Postgres. So yeah, it's really about, there is this giant list of functions somewhere in the source code. But also if you explain the query, it'll show like, hey, these and these functions, they're not on our allow list. So that's why you get this query plan, basically.
Yeah, so that defines what you can offload to DuckDB. I was more asking in the alternative path of, let's say you did not build your own custom scanner and you're just agnostic to the queries. How would it look like then? Like you still need to modify the query somehow to fetch from S3, and that has to go through DuckDB, right?
Right. Well, yeah, I mean, in the most extreme case, like you just have, I mean, you like once you have an Iceberg table, by definition, your query will have, let's say, a custom scan in the query plan, and then as part of that custom scan, also like the initial set of filters on the table in Postgres will be evaluated. So the custom scans job will then just be pulling from S3, and it just does that by doing a select star from read Parquet in DuckDB.
So that would be the most naive.
Yeah, that'd be the slowest option. And I mean, if you do select star from table, that's also what happens by definition.
And is that what a foreign data wrapper does?
Yeah, so the foreign data wrapper is like a machinery that helps with this. So I mean, we're kind of almost like hiding the fact that we're using foreign data wrappers, or like we're sort of using a mixture of APIs. But like an Iceberg table in PG Lake is essentially a foreign table. Foreign data wrapper is kind of the implementation of a particular type of foreign table. So we have an Iceberg foreign data wrapper. And that does some of this, like that has these APIs that allow us to work on the query plan. And that also, like if you're doing the select star from table, like you'll just get a one, actually you'll get a custom scan, but like you'll just get one scan which will say something like, oh, scanning this foreign table. But then we kind of also augment, like we're not quite happy about how foreign tables behave in terms of user experience, and B, there's just things we want to do that the foreign data wrapper APIs don't let us do. So we also kind of break out of that boundary a bit. And when you create an Iceberg table, you just say create table using Iceberg in PG Lake, which is not the foreign data wrapper sort of way of doing things. Like you normally say create foreign table, and there's something like a server, and but we just didn't like that syntax for this purpose, so we sort of changed that. And then we also have sort of layers around the foreign data wrapper, if you will, that do some extra kind of planning optimization. Okay,
interesting. And what do you think about the Iceberg catalogs? What catalog does PG Lake use?
Right, yeah, that's an interesting one. So when we started, like the catalog landscape wasn't as well developed, or at least very much in flux.
In 2023.
Yeah. Mm-hmm. And so the REST catalog, I think, was, maybe more in a sort of proposal stage, or it was sort of not widely adopted yet. But we figured, like, so what's the role of a catalog? Like the purpose of the catalog is there in part because S3 cannot do transactions. And so the catalog's one job is to essentially transactionally store the location of the latest metadata file of the Iceberg table. So like if you write to an Iceberg table, you get a bunch of new metadata files. One is the top level file, and the latest version of the table is you read that by getting the latest metadata file. And so the catalog tells you where that is.
Yes, the catalog just has to atomically update the pointer.
Right. So given that we were doing this in Postgres, we were like, well, that's, Postgres is really good at at updating a string in a table. So, and there's also this JDBC catalog protocol, if you will, that already existed at the time, where it just, let's say Spark, you can point it at a Postgres server and use it as the catalog, and it just expects a particular table or view to exist. So it will do something like select star from Iceberg _tables. So we figured as long as we ensure that view is there, like we already get, like, not just are we just sort of privately acting as our own catalog, but actually also a big chunk of the ecosystem can use that catalog to query those tables. Of course, since then, the ecosystem has shifted more and more towards REST, which also makes sense. And so now we've also been adding REST support, so you can use external catalogs.
It feels like a good decision at the time, at least. One of the big critiques in Iceberg has been that this catalog layer and metadata layer is just overly complicated. That's what DuckLake tried to change too, by moving it inside of Postgres. Basically, it seems like it did something similar.
Yeah, I think they're almost like they're sort of inverted, where with DuckLake you're using Postgres usually as the catalog in the backend, and then you're using DuckDB as your query front end. And with PG Lake, you're using Postgres as your sort of query front end, and DuckDB as your sort of engine in the back end. I do think conceptually having a REST catalog is useful, because like within companies, if you wanted to share data, it's good to have some API that has some flexibility around authentication and authorization, where just sort of expecting half the company to have access to the same Postgres server isn't always reasonable. So, I mean, in that sense, using a REST API makes a lot of sense. I do think that the current REST protocol is not really very good. I mean, it's like to me, the one job of the catalog, again, is like to do these transactions on the metadata location. But like, for example, with the current REST protocol, you can do a transaction, you can write across multiple tables, but you cannot read across multiple tables, which makes no sense, because then you cannot really get a snapshot across multiple tables, which the underlying data store, which is very often also Postgres, would trivially be able to give you. Is like, here are all the current metadata locations transactionally consistent with each other. But there's no way to do that with the REST API. But I think it'll get improved over time, hopefully.
That sounds annoying. So what is the current support? And you support a GDBC catalog, which is your own implementation of a catalog, as far as I understand. And is there REST API support today, or is it planned?
Yeah, so you can create tables where that are sort of managed by some external catalog with the REST API, so you can query those. We do also support writes, but I think there's still some caveats around writes, and I think it partly becomes like, I mean, we anyway have Postgres transactions. Like, we cannot prevent users from writing begin, update Postgres table, update Iceberg table, commit, right? And so when the commit of the second part of that transaction happens elsewhere, it's essentially it's a bit of a distributed transaction problem. And so then there's different strategies, like, and then the problem becomes, I mean, in the happy path, whatever, but like in the failure case, like, one side fails, what do you do? And so there's different strategies you could follow. It's like, okay, well, Postgres committed, so we should push the catalog to also accept our writes, even if it didn't the first time. We'll just like keep forcing our way. Essentially, that's one way. Or you try to reconcile Postgres' state in case that the remote catalog changed. And so some of that logic is not quite there yet. So it's like, conceptually it works. Like, you can see it do writes to an external REST catalog. It's just, I think that piece, we still consider that to be a bit experimental. Like, we haven't added it to our docs yet. Of like, okay, this is don't do this in production yet.
Got it. So transaction support is iffy in that, because it's a difficult problem. But regular support, let's say you're not doing transactions.
Yeah, I mean, that's fine. I mean, reads works perfectly well. So you have Iceberg tables
writes
somewhere. Yeah, like with. So yeah, again, the problem of my Iceberg catalog. I mean, it's more like I think we commit to Iceberg first, probably. So then we, if then Postgres fails, like, oh no, actually that's not true. We commit to Postgres first, and then to the Iceberg catalog. But then we may have, like, your remote Iceberg might get stale, for example.
No, I meant a batch write in terms of, let's say, select star from Postgres table, insert into Iceberg table. Right.
Yeah, so I mean, if you're just doing that, you're not also doing things on Postgres, that's just fine. Like,
yeah. So no writes on Postgres, no mixed queries. Yeah. I want to talk about ingestion patterns a bit then from that. So PG Lake is, from what I understand, is probably one of the easiest ways that you can write your Postgres data to Iceberg without any sort of overly complex ETL job or learning another tool or something. It seems that it's as easy as just writing, as I said, select star from Postgres, insert into Iceberg table, and if you're familiar with Postgres, you can set up some cron job or some other mechanism to keep track of what you've inserted, what you haven't, and set up a batch process like that. Do you see usage like that? Would you recommend people? How do you recommend people actually move their Postgres data to Iceberg?
Yeah, I think one pattern we see quite a bit now is, well, I mean, like, basically once, like, the predecessor to PG Lake, or like the first version, was called Crunchy Data Warehouse. Like, we were doing it at Crunchy Data, which has since been acquired by Snowflake, as a kind of a separate warehouse product. And so the first version that had like we released that in November 2024. And so that was Postgres with Iceberg. And then we released the thing and we immediately realized something's missing. Like you cannot easily just take, I mean, quite often what we see is like really large tables in Postgres are mostly append only because that's how they get large. So people just log events in Postgres, and it's nice because it, just like, especially with serverless applications or you have a lot of devices, like batching becomes complicated. So they can all just talk to Postgres, do a 1 millisecond insert and disconnect. But then how do I get all that append only data into my Iceberg table so it can actually be fast? I mean, there's kind of two patterns. One pattern is you treat your Postgres table as a queue, so you keep sort of just deleting from it and inserting into Iceberg. And that's just something you keep doing periodically, and it's a transaction, so if occasionally it fails, that's fine. We'll just not delete stuff. And while we're deleting, we can also keep inserting, so that works well. But if you want to keep some of your data in Postgres as well, because maybe you're doing fast lookups, then that's not an option. So we developed this extension called PG incremental, which is essentially a layer on top of PG cron, which is the Postgres job scheduler. PG cron is something I created like 2017. So PG incremental is like sort of PG cron plus essentially. And then it's still like you run a periodic query, but it sort of does some of the incremental processing bookkeeping internally as well. And so the query you define, it has some parameters. So it could, for example, have a range of sequence values. So let's say your table has a sequence column, so a number that keeps incrementing. And you write this query which selects sequence values from $1 to $2, where those are the parameters. And then you keep running that query, and each time the query runs, it'll get a new range. And then the extension internally makes sure it does the bookkeeping, and it also makes sure that there isn't any concurrent write going on that will still kind of insert a lower sequence value after you've started selecting this range. So it's kind of a safe mechanism where you can you write your insert select query, insert into Iceberg, select star from Postgres, where sequence ID equals or greater than $1, less than $2. And that's it. Like it'll just sort of keep shuffling over your data into Iceberg. So that's quite a popular pattern. There's variations of that where you take like an hour worth of data and things like that. And then I think in the I think the nicest pattern in a way is if you can do like just complete end-to-end replication where you say you have inserts and updates and deletes. There are a bunch of challenges in that pattern. We do have a version of that in Crunchy Data Warehouse. That is not currently part of PG Lake, but we're also kind of like rewriting it because there's certain aspects that we were not yet happy about that we think we can do better.
Got it. So it seems like the append-only workload is easy to get into Iceberg via something like PG incremental. That's exactly what I was thinking about, by the way, when I said PG cron. It seems like you abstracted that extra logic that has to be on top of PG cron, like keeping...
Right. Yeah, so you don't have to think about the bookkeeping yourself. That's otherwise you can still do it using PG cron, just then you write some big PLPG SQL function to do all the stuff.
Yeah. That's awesome. So you said you had some of these features in Crunchy Data Warehouse. Were you talking about the deletes and the updates?
Well, yeah, the logical replication that's sort of end-to-end.
And you also said that you made PGCon in 2017. That was when you were at Citus Data. You've had quite the career in Postgres. Can we talk about that a little bit?
Yeah, so my career started at Amazon Web Services in 2008 when there were 3 web services, EC2, S3, and SQS. Now there's 400 or something. And so we were, I joined as an intern, but like the team was already, was still pre-launch, but they were working on what would be called CloudFront, sort of CDN for S3. And then we later built Route 53. And then I went to do sort of a PhD and then also simultaneously kept working for Amazon. And when I was done with the PhD, I sort of had to leave Amazon. Well, partly it was getting bigger and I was doing less coding, and like I think you've had a similar experience. And partly I just had to finish my PhD, so I kind of had left. And then I started looking around, and then some former Amazon colleagues had started this scale out Postgres company initially from Istanbul, but they had to move to San Francisco because they had started Y Combinator. And the VCs want you to be there. And I wanted to stay in Europe. I was doing my PhD in Dublin. I wanted to go back to the Netherlands. And so they were looking for a senior engineer in Europe to help out their Istanbul team. So that was in 2014. So that was when I started working on Postgres and Postgres extensions. And so Citus Data, their goal was to build a sort of scale-out version of Postgres. Initially, it was a fork, very briefly, but we at some point hired Andres Freund, who was like one of the Postgres committers, and he found a way to turn it into an extension. Later, he became famous for saving the world from like a SSH vulnerability that was like last year or the year before. But from that was probably in 2015. So Citus simultaneously became an extension in open source. And so since then, I've just been doing Postgres extension development. And I guess pgcron is the most popular one I wrote. There's some other things, bits and pieces we've done. Though Citus was a really big and complex extension because you're trying to do this paradigm shift of you're taking a single node database and just by doing a plugin, making it distributed. And now every DDL is like a distributed transaction, and there's rebalancing and lots of stuff going on. So we explored every possibility of extending Postgres. And then, that was Citus Data was acquired in 2019 by Microsoft, which was starting to enter into the Postgres space and wanted to have a little bit of an edge that other companies did not, because Amazon was already quite mature with RDS, with Aurora. And so Citus was a way for them to A, bring in a lot of Postgres expertise, and B, have some unique features. Then at Microsoft we continued doing Citus development. I think probably the nature of doing a distributed OLTP database is we were kind of out of low-hanging fruit, and the level of investment it needed to take the next step, that was a little bit difficult to get sometimes. But I mean, it is actively used in production at very large scale at Microsoft. It was even already before the acquisition, the Windows team had started using Citus for their telemetry data. Whenever you install Windows, it asks you, can we send everything you do to telemetry to Microsoft? And then we also started developing some other things. It was sort of early on, helped create this PG document DB, which is basically an implementation of MongoDB on Postgres. So using index extensibility and type extensibility to essentially exactly mimic Mongo's behavior in Postgres. So that's kind of an interesting project.
Wait, where did you build this?
At Microsoft, it was in 2000. Okay. 2020 we started. So it's now called PG Document DB or just Document DB. I didn't do the heavy lifting. There's another engineer, Vinod Sridharan. He did a lot of the heavy lifting, but sort of I was mostly involved in the first year to kind of get it off the ground. But it's gaining a lot of traction now as well. Just to have use Postgres as a MongoDB alternative. So I've a bit of history in Postgres extensions.
Citus. The Citus extension sounds really interesting. Actually, I would like to dive in more, but I'm not sure we have enough time. And then, what about crunchy data? You didn't talk about crunchy.
So yeah, then after a few years of Microsoft, well, you know, like that's at some point, similar to Amazon, you kind of get worn out. But I started seeing these trends. I kind of got a bit closer to the DuckDB world, and I guess like I was co-supervising a master student, and her other co-supervisor was Peter Bons, who's like the sort of head researcher at the group where DuckDB is from. And so I started sort of just seeing more of it. And I sort of still kind of like, again, like a lot of Citus, people who came to Citus, they actually had this need for a data warehouse, which was still unfulfilled. And then, you know, Iceberg started showing up. So like all those kind of things started coming together of like, okay, we need to do something in this space. And we actually sort of, with two longtime colleagues, we really like Ander and Kalaje and Utku Azman, like we really like working together. And so the three of us actually started looking around for, okay, where could we do such a project? And so we talked to some companies, and Crunchy Data already had a bunch of former Citus employees, like Craig Kirstjens, who ran the cloud business. And so we kind of knew them pretty well and knew that they would build a sort of very solid platform on top of which we could release this without getting bogged down into like operational issues. So then we, and I think it was a nice way also for Crunchy Data to have something more differentiated, because traditionally Crunchy Data was more Postgres consulting, then they got into Postgres managed service, but it's still like stuff that other people do. And so with Iceberg, it was getting more differentiated. So that was a nice company to do this at. It was, I was actually like not expecting, I was expecting the journey to be a little bit longer at Crunchy Data, but then 1.5 years in, we got acquired by Snowflake. But it's also a nice opportunity now, for example, you know, for Crunchy, this was really like a differentiating feature, and it was something we were selling to on-prem customers, and that's also why it was more kind of proprietary. But now for Snowflake, it makes a lot more sense for it to be open source as PG Lake. So,
yeah, that's quite the experience. Now, how are you differentiating Snowflake? What's your role there? What are you working on?
Yeah, I think the fundamental way in which, let's say, Snowflake Postgres can differentiate itself is really by just making it really, really easy to get data in and out of Snowflake from Postgres, right? Because there's and PG Lake, we sort of treat it as a building block to that, but you also kind of just want to create these simpler experiences of I see my Postgres server in Snowflake. I see that it has a bunch of tables. I want this one, this one, this one. Mm-hmm. Make it show up in Snowflake with minimal lag, and do the updates and deletes and everything. So because then you don't need the whole kind of ETL pipeline and intermediate systems. It's just and a lot of existing Snowflake customers have this problem. Like everyone has Postgres at this point, so they have Postgres. It's running somewhere, and it's just very hard for them to get the data into the data platform that they're using. So that's kind of a key thing about Snowflake Postgres. And we'll be building new extensions as well, but that's the current focus.
Yeah, as an observation of mine, I feel like every company is building their own first-class sync tools or integration tools, basically.
Sure, yeah.
Like you have the Kafka of the world, and let's say you use Debezium or Kafka Connect or some other thing to connect the stuff, but I see everybody sort of seeming to build first-class integrations because these are just, I guess, too hard to use. You've had a rich experience. So you have AWS, you have Citus, you have Microsoft due to that, you have Crunchy, now you have Snowflake. Can you tell me so you have experience in the data infrastructure world and also in the Postgres database world. Can you tell me what your main observations off of those many years of career time been to something that somebody today may not be obvious to somebody who's new or who's outside of the space?
Right. Well, Well, everything is different now. Well, like the area that as I found pretty interesting lately is just this and it took me a while to really grasp it, but the operational and analytical database sort of separation and like, I mean, I sort of like seeking out these sort of impossible problems and then just see how far you get. Like, I think 10 years ago or 12 years ago, like, you know, the notion of a distributed relational database was seen as this sort of impossible problem. Like, you had the sort of NoSQL databases; those were distributed, and you had SQL databases. Right. And it's like, okay, that's an interesting one. Let's see how far we get. And it's a type of problem like you don't necessarily solve it, but you learn so much trying to solve it that it puts you in a pretty good spot. And so the impossible problem I picked up next is like, okay, how can you bring OLTP and OLAP databases together? And again, like you're not going to have a magic bullet of okay, this database just does everything perfectly. Okay, I maybe CedarDB is trying to claim this, but like I don't believe it. And I think also part of it, you know, I've really noticed that like people who work on operational databases, they don't understand analytical databases, and people who work on analytical databases, they don't understand operational databases, because they have this very weirdly different development cycles where in an operational database, something can just easily take 10 years, which would take 6 months in an analytical database. And the reason is that the trade-offs are just so different, and particularly around in a transactional database, you're in this sort of constant state of misery when you're doing development, because everything you try to do ends up slowing the database down considerably in some way. Like any kind of new MVCC mechanism, snapshot isolation mechanism, like if you try to be smarter about foreign keys in some ways, you'll find it'll get slower in other ways. If you try to be smarter about logical decoding, you'll find that it sort of creates a backlog somewhere. It's like it's sort of this very tightly coupled system, and analytical systems they're a lot more flexible in that regard, and you can see these evolving architectures of like Lakehouse. Now we're combining different components into a database essentially. But I find that a very interesting area to be working on. This sort of impossible, like, there's the sort of system architecture aspect of it, and B, there's the sort of almost social aspect of it, that there's these different groups with different practices, and they like it's very hard even to explain like to one group like why the other group is taking 10 years to do something.
It's like, do you think that's because the OLTP databases are just frankly just more mature? As you've said, like Postgres is a 40-year-old technology and it's seen such massive use since then, whereas the OLAP thing I feel like is a somewhat relatively newer phenomena of having more data to analyze.
Yeah, I mean, I think all databases, they have been coming and going for a while. If you go back to like Teradata and Astrodata, and I think Michael Stonebreaker probably had some as well. I think OLTP databases are mature partly because it's so hard to build an OLTP database that's actually good and versatile and performant, and like the ones that are newer just don't work as well. Like that's the old ones in that sense. Whereas with analytical databases, you can innovate much faster if you come up with some better query engine. Like the rest of the pieces, they can be rewritten or adjusted much quicker than they can without repercussions. And so you kind of see a lot more newer generations of analytical databases going from Teradata, Vertica, Redshift, Snowflake, and things like DuckDB and ClickHouse appearing. and also some of the existing analytics system getting faster. So it's a different innovation cycle, I think. I don't think it's necessarily maturity. I mean, like analytical databases can do a ton of things which operational databases cannot, that you would just really like sometimes. Snowflake, there's like these data sharing features or dynamic tables or streams in Snowflake. Like, I see all these things. I wish I had that in Postgres. But then I think about how long would it take me to get this into Postgres? And I was like, probably like 10 years. Like, need to.
But is that the technical complexity of the feature, or is it also just the open source community and just?
I think it is a bit of both. But I mean, like I think sometimes like it's hard to get stuff committed into Postgres. Partly like it's like there's a sort of logistic aspect to it, that it's a mailing list and you send patches as attachment to a mailing list, which is super weird. And then you need to get a committer to pay attention to your email thread, and there's a social aspect to that. But like it's a model that's evolved and survived, and it also has a reason for existing that has a lot to do with how hard it is to develop Postgres. Mm-hmm. Like committers are terrified of committing a patch because it is like so much critical infrastructure of the world runs on these databases, right? The analytical databases are downstream. Like OLTP databases, they're in the fire bits. Like they're running hospitals, they're running factories, they're running ships, they're running like everything. And so if something goes wrong, which causes like widespread data corruption or something, it's like there's almost like no way to revert. So it's good for committers to be very cautious, and like the way in which Postgres gets developed in a way has maybe helped it get remain very sort of reliable and stable and predictable, and help it gain popularity. I think also like Postgres has been, it's very rare for, let's say, a new Postgres version to regress on performance. Like, MySQL has had this saga of like 5.6 to 8. It's like, 8 was so much better in so many ways, but it's also much slower on some workloads because it now actually does a lot of the things correctly that it wasn't doing in 5.6. And so a lot of people were not upgrading because it was just too much of a regression. And so you won't, like, in Postgres, they try to sort of never make it slower, but to not be slower on all workloads, it slows you down enormously. Yeah. But at the end of the day, it's still like, well, nothing else is there that has that same sort of trustworthiness and same versatility that you get from Postgres. So like the process seems to work, although it's frustrating at times. And extensibility is kind of nice, kind of way to escape from it, that if you want to do something a bit more ambitious, you at least have some options to do that. Like it's and maybe it could be faster somehow, maybe there could be a much better process. It's just but there's also like there's certain features, like, so Snowflake, you can see every query you ran in the last 24 hours or 48 hours, and like the results of the query, the runtime, the query plan. If you think of like translating a feature like that into Postgres, it's just a really bad idea, because it's, maybe you have 100,000 queries per second. Where are you going to store all of that information, right? Like, so it's a bunch of stuff just doesn't translate as well. But it's very hard to sort of see where that boundary lies, actually.
Makes sense. Yeah, they're definitely different systems. So from that point of view, do you ever see them actually converging, as some people are trying to do?
Well, I think more in the single. Some people say single pane of glass. Although I think that term gets abused. Something like PG Lake, where now I have, I still have my operational Postgres, and then I can also do fast analytics. Though it's not, it's not distributed, so I cannot do everything I want. I don't have all of the data management features, but it does seem to point towards a, I mean, some people have been calling it like Postgres as the control plane, or like Postgres as your gateway where you enter your data management platform, and then underneath it kind of branches out into different systems. Like some part of it will be handled by the operational engine, and some part of it will be handled by other engines. But at the top, you still have, the same protocol, the same API, the same transactions, perhaps. So I think there's definitely like a trend in that direction. Whether you, okay. I mean, whether that will take over the world, I would probably not. But I'd see them architecturally converging as like, okay, this is the one true architecture that does operational and analytical workloads really good. I'm skeptical, but
and what is the driving force behind people wanting to merge these in the first place? Do you have what does a production OLAP query today look like, and what does it have to do with Postgres? Actually, I've heard this term of so-called reverse ETL, which is you pull analytical data from your OLAP store or your whatever lake into the operational context. Have you seen that happen? Do people do that?
Yeah, for sure. I mean, it's kind of the case where your dashboard talks to your data warehouse, and it's a little bit slow. It doesn't support a lot of concurrent users, and you make it fast by getting the data into Postgres. I think that's the typical reverse ETL use case, where you actually sort of pre-aggregate your data, or you collect all the data in your data warehouse, do all the cleanup, and then pre-aggregate it, and now you need a fast presentation layer.
Okay.
There's also some more applications of that in things like machine learning, where it's like you have a sort of online feature store where you need to look up things quickly, which maybe uses Postgres. And so it's basically a way to take data from your data warehouse and make it sort of presentation ready, or if you want a fast presentation layer, you put it in Postgres. I think that's like the vast majority of reverse ETL use cases.
Okay, that's a thank you for that. I didn't know that. And have you seen cases where people want to merge the old-time data, the old data and the new real-time data together?
I think people do. I often have mixed feelings about that, because I mean, I think they sort of intuitively want it for simplicity of, I just want to have a single place where I can go and query across these fresh data and old data. And it sort of makes sense from an ease of use perspective. It just, because of the architectural differences, you end up hiding a bunch of complexity that will show its face in terms of, in the form of sometimes very poor performance, right? Like if you do particular types of queries that are like, maybe you have a sum table that's like part Postgres table and part Iceberg or something, and sort of like there's this sort of transparent layer on top, and data gets automatically shoveled over. It's great, looks perfect. But then like there are certain types of queries you do which actually benefit a lot from hitting the Postgres part of that table, because they very selectively filter, and they use indexes, and they just within a millisecond find the right rows. But then maybe you do this for the last 7 days and it's great, and you do it for the last 14 days, and now your query takes, instead of 4 milliseconds, takes 17 seconds or something, because now it actually has to go and sort of pull in all that older data. Maybe in the happy case it's cached, maybe in the unhappy case you've just switched to a different server under the covers, and now it's not cached and it's all slow. So it's really hard to hide that type of complexity, and like it's never as easy as you would dream it to be, like as a user. But like people want it. It's just delivering is the tricky part.
And it's funny you say 7 days, but I'm actually thinking a time span of, let's say, minutes.
Right.
A well-oiled, let's say, lake ingestion pipeline can get your data in the lake like with a lag of as much as, let's say, 15 minutes, I think is a reasonable sort of trade-off. So if you have, let's say, all of your old data in the lake, somewhat duplicated to the operational state, and it's, let's say it has a 15-minute lag from right now, you could still reverse ETL that into, reverse ETL with all the historical data that's more than 14 days old, etc., into a view or a table or whatever you would do. And I feel like that's good enough for a lot of cases. So when I say merging both, I'm thinking about that 15-minute of newer data that just came in. It hasn't made its way to the lake and hasn't been reverse ETL'd back.
Right. Yeah, I think that's okay. So this is like it's sort of a two-way street where new data is coming in via Postgres and is some kind of pre-aggregated in the data warehouse and then also reverse ETL'd back. Yeah, that's interesting. I think a lot of time these things are a little bit separate. That one server is dealing with the dashboard and the reverse ETL, and one server is more kind of the ingestion pipeline.
Sorry, dashboard is one thing, but I'm also thinking about, like you said, like for an AI use case. So how I imagine it, you can tell me if that matches your understanding, is you have an AI chatbot or an agent or whatever the buzzword is, and it wants to ask some context of a user. Let's say I'm a customer of Amazon, and it wants to pull up all my historical orders, all my activities, so it can give me a nice answer. I assume that's a case where you would want reverse ETL, but let me know if you agree with that. I hear these narratives, but I don't know how much they're actually happening in the real world.
Right. Yeah, they are happening. I mean, usually the architectures are a little bit more elaborate, let's say, with different bits and pieces, and it doesn't sort of loop back to Postgres usually. That's kind of an interesting model. But the other thing that once Postgres is more of a first-class citizen of, let's say, a data platform, the data platform could just also just on demand get new data that it wants from Postgres, right? Which is kind of interesting. So I feel like in this minute case, so maybe the vast majority of data is in, let's say, Snowflake, and then last 10 minutes is in Postgres. Like it could sort of just fetch it as needed for certain types of queries. But then if you have more of a loop, then there's the question of what's the difference between the before the loop data and after the loop data? Is it just that at the end of the loop it's aggregated, and then could we not have just done the aggregation in Postgres itself? Did we need to go through the data warehouse? I know it's like
but it's if you don't have the historical data, I guess.
Yeah. But I mean, there's definitely a lot of interesting things that are probably still underexplored that you can do when you have more properly integrated these architectures, where currently the Postgres database is just sort of this far away silo compared to, let's say, something like Snowflake. And so that's also, I think, why you now see all the data warehouse vendors, whether it's Snowflake or Databricks or ClickHouse, they kind of all built their own Postgres services, because you can make more interesting integrations that way.
I think that's a good point, that they're very isolated. I think, from my experience, DBAs usually pretty much guard the Postgres like they're only child. And for no reason.
Yeah, and that's where, I mean, having it, you only really trust the DBA and the platform, right? Because platform you have to trust, so... But that gives, if you're trusting, let's say, Snowflake to run your Postgres database, you're sort of also trusting them to do the right thing when it comes to data integration. And then you're implicitly trusting people like me that we're not going to actually send super large sequential scans to your operational database. There's a lot of challenges to be figured out there. But yeah, so I mean, this has happened over the last year or so, right? That data warehouses have started running Postgres. So there's still a lot to be explored, I think, in that space.
And if we look at Postgres as a lake, this idea of Postgres as a lake, with the caveat that it's not actually a lake, but it's using DuckDB, or it's probably good as a part-time lake and not for everything. What do you think is the ideal future or ideal adoption of this? Where, in terms of, let's say in a few years, how do you think, if in a few years we were able to say this PG as a lake idea really won, and it was a great idea, how do you think that would look like? How much data would one actually have to use a lake and to use Postgres to query it, how much would they actually query versus offload to a Snowflake, ClickHouse, whatever else? How are you thinking about that?
Right. Yeah, because like, I mean, one interesting problem to solve is the catalog piece. Like, can we make that really good? Whatever good means, because then I imagine like you might actually have a whole bunch of these things. Like, every application might have its own Postgres server, but and maybe they'll use PG Lake. Like, this is a very nice way for them to share state in different forms. But let's say they could be appending to the same Iceberg table, or they could be exchanging stuff via Iceberg, and also with other systems. And I mean, in theory, you could sort of maybe do something like that with REST catalog. But anyway, let's say if REST catalog gets a little bit better, if our implementation gets a bit more polished, you're actually a good way of the good sort of part of the way there. It's partly then about figuring out the right patterns. Like, if I have, I don't know, let's say 10 Postgres servers doing ingestion and they all append to the same Iceberg table, can I make that work really well? I mean, that's a very kind of interesting thing. Now I can scale to millions of single row inserts per second that I can just accumulate in the same table and query somewhere else. And so I think that's one important direction of like smoothing out the whole catalog and multi-node story. And I think of the multi-node story partly as scalability. Maybe that's just because I've been in that space for a while, but it's also, I mean, like, if you look at the sort of the software development trend, it's like everyone's going to be writing their own applications for everything soon, like, or now even, right? It's very easy to go into Claude, say, okay, yes, I have this business problem, so rather than using SAP or whatever, like just write this application for us. It needs to store this and this, put it in this Postgres database. And so you're going to have a lot more Postgres databases, and you need some kind of fabric to glue them all together. And I think with Iceberg is a very interesting way of doing that.
That's a great observation. So you're sort of seeing Iceberg and potentially this integration from Postgres to Iceberg as this, let me call it like a asynchronous, maybe lower guarantee shared table across many different Postgres instances. And maybe you have like a proper governance structure and everything. But it sounds a lot like what Kafka was trying to do, actually, as a place which gathers all of your organization's data and becomes like almost like a central nervous system, or at least like the common storage there for data. I think that's really interesting. I also saw some potential for Iceberg to do that. Perhaps the devil is in the details, as you said, in terms of, let's say, the catalog API and also like what use cases, but I think that's spot on. I think definitely we're going to a world where there's going to be a lot more little apps needing some sort of little database. It could be an SQLite, could be a Postgres, but some of their own database. And this old model of one shared database for a lot of apps, I mean, we already know it doesn't work with a proper microservices architecture. It also doesn't use just one database usually.
Right. Yeah, now I'm kind of sort of thinking is like, how does like having deeply integrated Iceberg contrast to having deeply integrated Kafka? Because I guess there's sort of Kafka SQL type things as well. So
it's different. The streaming SQL is definitely very different. I don't think Kafka ever did a very good job in this sort of integration apart from narrative, because I think it's a lot of work to actually integrate applications like that. And some people have done it successfully, but they sort of did themselves. I think SQL is difficult to integrate. I guess that's what I would say.
Yeah. I think Kafka is like it does the scaling really well. I think,
yep.
And it sits more of that at the higher end of the market. And like in theory, Iceberg was also like more of a higher end of the market tool, but like there's been a bunch of good tooling that has made it a lot more accessible. I mean, I think DuckDB as just a sort of general purpose vectorized query engine that is good at scanning Parquet files, and also data fusion. I mean, in a similar trend, is like that already takes away a big chunk of the problem of like, okay, how do I actually scan the data? And then it sort of reduces into, how do I deal with all this messy metadata? And the metadata is relatively messy, but it's still it's a manageable problem. I mean, like Iceberg is not the most accessible thing, but I mean the tooling is good enough for it to even be on the lower end, kind of an appealing thing to do. Of like, hey, I insert into Iceberg from this small server, and now I can also query it from this my data platform without a lot of extra steps. So
that's interesting, because I was thinking, I want to ask you about this idea of the big data separation versus small data. And Iceberg to me definitely feels like a very big data technology, as is Kafka, but Iceberg is definitely less mature because it's newer. I tried to spin it up once with a Polaris catalog actually in a year and something ago, and I found it really difficult. Things move fast, so they've probably changed since then. But as you said, also the metadata mess, so just the way the metadata is made to be, it's obviously taken some trade-offs to accommodate for high scale rather than ease of use. So it seems like you disagree with that in a way where you think actually Iceberg may be a fit for, let's say, a typical small data use case in an architecture.
Yeah, I mean, I think that the tooling is catching up. I mean, it really comes down to like how much energy does the ecosystem ultimately spend on it. Like you could make any technology work if the whole world is building better tools and infrastructure for it. Like I think that the nice thing about Iceberg, even for small data, it's like once you sort of get over the initial hurdle of like, okay, I need a catalog and that kind of stuff. But the fact that, I mean, it is essentially just well-defined, updatable, relatively self-contained Parquet in object storage. I mean, I guess a key thing about Iceberg, it's like open formats in object storage. At the end of the day, it's like,
yes,
Parquet, Afro, JSON. Like, okay, I don't know why it has to be three different, 4 different file formats, but like, okay, it's open formats in object storage, and like, you know, that's. I mean, I think part of the Iceberg story is really the object storage story and the open format story. That, okay, everyone is agreed on object storage as the thing that is just the way we communicate almost. Like you almost don't even send messages directly between systems anymore. Just put stuff in object storage and fetch it from there later. And then, yeah, just having a well-defined format. I mean, it's not brilliantly designed, but it's just well-defined enough that, okay, I can do updates and schema changes in this model. There's some statistics, so I can scan reasonably efficiently. If I get to a larger scale. But even for smaller scales, I think just that having that as a protocol that we all sort of agree on, that, you know, both Databricks and Snowflake support, and DuckDB and Fiji Lake and
S3.
Yeah, a variety of other tools, S3 tables. Like, I think that makes it very, very powerful. I think it's just it's almost sort of. I sometimes think of it vaguely as a sort of TCP/IP for tables. Like you now actually have a well-defined, universal way of exchanging tables rather than just messages, which I think is very interesting.
That's a pretty good take. I think people underappreciate this network effect of open formats. Kafka sees something similar. Kafka is still basically the king of messaging. There have been many people trying to create something simpler, and you can go simpler than Kafka. You can simplify the API and everything, but the network effect has grown so large and the ecosystem is so large that at some point you make the choice of, well, I'll take this maybe slightly more complicated thing, but in aggregate it makes my life less complicated because I don't have to learn another technology, I don't have to deal with its immaturity, and I don't have to teach other people about this, you know, yet another API. So I guess maybe Iceberg can see something like that.
Yeah, and I think, I mean, in theory, let's say if if through some alternate history, like Kafka had the type of energy in the ecosystem that Iceberg has now, right? Like that there's people just like saying, well, here's a button in Postgres that sends your change stream into Kafka, right? You don't need to set up Debezium or anything; it's just built in, right? I mean, it could have a similar like even on the small scale, like on the large scale, I think Kafka is still like the thing to use. But on the small scale, I think it's really comes down to the network effect and the ecosystem.
Awesome. Well, I have a final question to you.
Sure.
In 2026, if you had, let's say, your own startup, you decided to quit Snowflake and build your own thing again, or be part of a smaller company again, up to what point would you use Postgres? I'm already assuming you would choose Postgres, but what would you talk to me about the just use Postgres fever that the whole industry is in? How much do you agree with that? How much would you follow it?
Right. Yeah. I mean, at this point, I've been sort of institutionalized in Postgres, right? So I barely know other things. But yeah, I mean, I think it's I think the good thing about Postgres is not so. I mean, it scales pretty far, but the versatility is the kind of underappreciated aspect that, even things like you can sort of bet on Postgres even for things it doesn't do yet, right? Like with vector databases, it's like very quickly it became a pretty solid vector database. Even though it wasn't at all a few years ago. And what often happens is as you develop a product that gets more and more complex, the need for a more versatile data store is often greater than the need for a more scalable data store. And also because, you can often still throw more hardware at the problem and go quite a while and end up like OpenAI with 50 replicas, and it still works. So yeah, and in terms of versatility, I don't really think anything comes close, because there and any sort of more kind of rigidly defined, like all the more scalable databases, SQL databases, they're much more rigidly defined. They're often sort of managed. You cannot run it yourself. You cannot have extensions. So I think from that perspective, just from, okay, I'm building a company. I don't know what this company is going to look like in a year from now, but Postgres will give me the most flexibility to whatever is going to happen to my company. I think that makes it the safe just use Postgres bet. I think in terms of scalability, read replicas do take you pretty far. I think this is still, and to be honest, I've always underestimated this, how, when we're doing Citus, I think, the two things we probably I'd have done differently in hindsight is one is focus a lot more on the software as a service use case. I think we were always kind of a little bit, we can do some types of analytics, we can do some of this multi-tenant use cases, but focus more on the OLTP. But the other one is read replicas are still an extremely useful scalability tool, because most queries are still reads, and we sort of made it almost a binary choice of you use sharding and maybe you replicate your whole cluster, but that's a bit annoying, or you use read replicas, and I think having a bit more pragmatism around that is probably very useful. That some parts of my I'll probably end up with multiple Postgres servers, and maybe there's some degree of sharding, but read replica is kind of the main scalability mechanism. And then the tooling for read replicas could be a little bit better, because now it's all still this read replica is 2 minutes behind, this one's 5 seconds behind, and it keeps switching between them, and it's a mess. But that could be improved. But yeah, anyway, there's enough handles that you have to deal with scalability as well. But it's the versatility that makes it a safe bet in almost all cases.
That's one of the best answer. I think that's the best answer I've heard about that question. The future versatility. Data and Postgres, not just because it does everything today, but because it will do everything in the future.
Right.
That's awesome way to end it. Thank you so much for taking the time, Marco. I really enjoyed this podcast.
It was a lot of fun. Yeah, it's been great. Thanks for having me. This is I like talking about PG Lake and about Postgres, and so this has just been a lot of fun.
Yeah, I'm sure we could have talked for 2 more hours. Honestly, it's so
Probably.
much to talk about. But yeah, thank you, and have a great day.
You too. Thanks.